All right, let's get started. I'll have more to say later about the final, but I'll just tell you right now, there'll be a review tomorrow, basically going over the sample final and answering any other questions you have from 12 to 2 in here with Andrew and other TAs as they show up. If you can't make it, then it's going to be live streamed, so you can view the live stream if you wish. All right, so you're working on PS12, and it is due tonight or tomorrow with a late date. Any questions or problems about that? Is it working out okay? Yeah?
Should we fully delete the old Boggle service project and the testing stuff that we had next to it, or is it enough just to unload them?
It might be enough to unload them. There's just some mysterious interaction. If that old Boggle service project is present, it seems to run itself when you run the other project. Probably unloading it somehow. You're not having any problems in unloading it somehow. Yes?
On like PS10, we had the app data folder for putting our SQL database in. Should that folder exist in like any Visual Studio project, or do you need to create it?
It's not going to exist. It's not going to be created for you in any type of Visual Studio project. I guess any type that traditionally has a database in it, it probably is.
Okay.
So I think it was maybe Friday when people were having all those problems with port 60,000 being used, or the database in use, and they couldn't use their database, that it finally occurred to me to go look at the discussion forum from last year. And I was embarrassed to discover the exact same problems happening a year ago. So what happened a year ago is people reported those problems, and we figured out the workaround, and I posted it. And I imagine I said to myself, I will never forget this. But I forgot. But I immediately, this time I went in and actually changed the assignment to put these steps in. So when I use this again, I'm cooked. So sorry about that. That was unfortunate. Hopefully we got all that straightened out. All right, just before class I released PS10 grades. And I'll put up, I mean, for 10, 11, and 12, you have the test cases in advance, so there won't be a traditional regrade. But as always, if we make a mistake, you can tell us about it. So I'll put up the regrade form for that. I suspect that 11 and 12 grades will come hopefully pretty soon, hopefully before the final. Yeah?
I don't have a question about PS12, but I was curious, how do you assess grades at the end of the semester?
Well, what I do is I just grade the class. Everybody's got an average, from the high 90s down to whatever. I look pretty hard at where I try to figure out a pass-fail line. If your average is too low in the finals, that's a fail. But assuming you're on the exams rather, assuming it's not too low, I figure out the line between C- and D+. And then I basically take what's left and sort of draw lines at even intervals. I'm usually aiming for like a 3.0 class average, 3.0, 3.1 class average among people who actually took the finals. I don't include people that bailed on the course. And the net effect is that, in a strict cutoff, the traditional cutoffs between A's and A minuses and B's and B pluses gets shifted down slightly. But I can't be more specific than that. It just depends how what kind of mood I'm in today. Okay, any other questions? All right, so today I want to finish up talking about intellectual property and a bit about ethics. I'm sorry, but it's going to be a little bit rushed, but we're out of time. And then we'll talk about the final. I have a list of topics we covered, which is an impressive list, but maybe not the best way to review. So mainly it'll be question driven when we get to that point. So we're talking about copyright, and I was saying the last time we talked about it, that before the 90s, if you wanted to go into a criminal enterprise violating copyrights, you know, selling copies of movies or books or whatever, it took a big capital investment. You know, to create distribution channels and you know, a method of reproducing the thing you were copying. And, it was a big enterprise, and so it was hard to do and easy to catch, easier to catch. But in the 90s, mainly because there was an internet starting in the 90s, or web rather I should say, everything changed. Stuff started to be digital, and so it was easy to make perfect copies of digital material. It could be done so extremely inexpensively, essentially free to make a copy. They could be compressed and distributed via the internet. So suddenly it became very easy to do copyright infringement on a massive scale. And the catchphrase is, the cost is no longer proportional to the harm. And so the whole idea of copyright violation had to be revisited. And so what was created at the end of the millennium was the Digital Millennium Copyright Act. It was enacted in 1998. And it had a number of provisions, but I'm going to focus on just a couple. One question became, suppose you're an ISP, and people using the ISP are connected to the internet, obviously. Let's say they download a file. Well, as the file is being downloaded, it's being copied from the network onto a server and then copied off the server and sent somewhere. So, strictly speaking, a copy was just made. And people were literally wondering, is that a copyright violation? To make a copy while we're in the process of translating a file from here to there. It's not like a permanent copy. It may only exist for milliseconds, but it's a copy nonetheless. Or when you play, say you're streaming something off the internet and you're playing on your computer. You're making a local copy of it in order to play it. So is that a copyright violation? So they worried a lot about ISPs. And you could substitute Google or YouTube for ISP here. And they created what they called 4 safe harbors. So 4 things, 4 circumstances during which ISPs and the like could make copies of things without it being considered a copyright violation. One was transitory communications, like I just mentioned. One was caches on the system. One was information stored at the direction of users. What's that? Information stored at the direction of users. Yeah?
Is that if I download something, so the ISP has to deal with that data?
Well, it's not so much you download something, that'd be more like a transitory communication. It'd be more like you put something on YouTube. Right? So they didn't decide to put the video on YouTube, you did. It's being stored at your direction, but they're not, you know, they don't have any direct decision on whether to do that. And then information location tools. So that's, you know, Google, you know, search engines. So all that stuff is allowed to be done, but there's a catch. There's this thing called notice and takedown provisions, which we'll talk about next, of the DMCA. So in order to be protected, you have to cooperate with notice and takedown. The DMCA also contained an anti-circumvention provision, which made it illegal to basically to break copy protection, whether it's easily breakable or not. So this is notice and takedown, which you may have encountered before. Have you ever gone search for a video on YouTube and or Google or whatever, you get there and instead of the thing you're looking for, it says this was found to be a copyright violation and has been taken down. Has everyone ever seen that?
Yeah.
Okay. So that's the notice and takedown. So the way that works is, if you're YouTube, let's say, you have to designate an agent who's in charge of these things. So a notice and takedown agent. If say NBC notices that there's a copy of last week's Saturday Night Live on YouTube, they can, if they wish, contact the agent and say, hey, we have the copyright on this show. We didn't approve it being put up, please take it down. And what YouTube would have to do is remove the material, so take it down. They don't judge whether NBC's claim is correct or not. They take it down. They're obligated to take it down when they get the notice. And they notify the user who put the material up. Now, the user then has got some time to notify the ISP that, no, NBC is wrong. They don't have the copyright for this thing, I do. And if they get that counter notification, the ISP has to put it back up. And then, but in the process of going through this cycle, NBC can, or YouTube can now put NBC and you to get, you now know how to connect to contact each other. And then basically that when NBC can sue you if they wish. So the whole thing is set up so that things get taken down quickly, but if the claim that took them down is incorrect, they can get put back up quickly. And then the two parties work it out independently of YouTube in this case. So things often go down. I don't often see things go back up as they come down. Because I think the most likely thing, the most common case is it was legitimately copyrighted material that was posted in the first place. But that's all a result of the DMCA, that happens. So the anti-circumvention provisions of the DMCA prohibit making, distributing, or using tools designed to circumvent copyright protection schemes. And that's been employed at times. Here are some capsules of times that the anti-circumvention procedures have been used. This is my favorite. Secure Digital Music Initiative issued a challenge, challenging people to try to break their copy protection scheme. And so some researchers at Princeton took them up on the offer and found a way to crack the protection scheme, and the professor was prepared to present a paper on it, but was sued by the Secure Digital Music Initiative or threatened to sue, to prevent the presentation of the paper. The researchers sued back. For whatever reason, the papers weren't presented, and so it became a moot case. This is the case of a Russian who sold a program to break Adobe copy protection, ebook protection, and basically arrested for getting off on the plane in California. So this has been used to suppress people trying to break copy protection schemes. Before we move on from copyright, I want to say something about the Free Software Foundation. So when you hear the term the Free Software Foundation, what do you think of? Yeah.
Open office.
Okay, open office. Yeah?
VLC.
What's that stand for?
Video link client?
It stands for the Video LAN Client.
Video LAN client. Yeah?
GIMP.
GIMP. Yeah?
Most Linux-based programs.
Okay, a lot of Linux-based utilities. So the Free Software Foundation, the word free doesn't mean free of charge necessarily. It's talking about freedom to reuse the software. So the Free Software Foundation is dedicated to eliminating restrictions on copying, redistributing, understanding, and modifying computer programs. And they have a, they call it a copyleft language they can use. So if you copyright your software with the copyright notice provided by the Free Software Foundation, basically what it says is you are free to use this anywhere you want. You can take the software that's protected under this copyleft, and you can reuse it, redistribute it, rewrite it, do whatever you want to with it. But anything that you use it for, if you embed it in another program, that program has to carry the same copyright. So if some commercial program, if they attempt to use stuff that's protected by that copyright in their program, and then they put a more restricted copyright on the result, they're in violation of the Free Software Foundation copyright language. So that's just this organization that exists to promote that approach. That doesn't mean you can't take their software and sell it for profit if you wish, or take protected software and try to sell it, or put it in commercial software that you do sell. It just says that the resulting software has to be free of copyright restrictions, basically. That's what I'm talking about here is the GPL. That's the copyright language I'm talking about. Okay, that brings us to patents. So remember, copyright is a way to protect expression. Writing, song, architecture, art, whatever. And copyrights are automatic. Anything you create and put in some tangible medium is automatically copyrighted. Patents are to protect ideas. So what you can patent are new inventions, and that's defined as things that are not obvious to someone skilled in the art. And there are lots of arguments about that. People will patent things, and you'll say, that's just a completely obvious thing. How did that get patented? And that just happened because the patent examiner had a different definition of what it means to be skilled in the art. You have to patent something that has a useful purpose and works. Okay? So you can't patent time machines or perpetual motion machines because they don't work. Unless you can demonstrate that they work, I guess. And gears isn't specific enough. It has to, gears by themselves aren't useful. Gears in some application is what gears in use is what you can patent. It says here you can't patent discoveries about the natural world or plants or animals, and yet there are companies that have patented genes, human genes. For example, Myriad Genetics, yes, up in Research Park. They have a breast cancer test, and it's expensive because they patented it, so it can't be, they have a patent on the gene that is used in the test. So there's a mutation on the gene that correlates with breast cancer, and they have a test that looks at that mutation. But they have succeeded in patenting that. And so competing companies can't base a test on that same gene. It just seems kind of weird to me. If you can't patent discoveries about the natural world, how do you patent a gene? They have done that. Software patents have not existed since the beginning of software. They only started appearing in the 1970s. And so, in a way, we'll see the patent system is based on the assumption that you can tell what's a new idea by looking at whether it's been patented in the past or not. But since software, a lot of stuff was discovered about software, a lot of inventions, all these programming languages were invented and programming techniques that weren't patented because people just didn't think they could patent software until the 70s. So that's made it, determining whether something's truly a novel invention kind of difficult for a long while in the case of software. VisiCalc, I can remember VisiCalc, it was the first spreadsheet. I think the guy, his name was Breckley. So he developed a spreadsheet, this idea, he conceived of the idea of a digital spreadsheet, and his lawyers told him he couldn't patent it. And so he didn't patent the idea of the spreadsheet, and of course the idea spread like wildfire, and lots of other people profited off of it. Him not so much. Probably got bad advice, because that was maybe the beginning of the 80s that he did that. And as we've mentioned before, to obtain a patent, you have to disclose the invention. The idea is to advance the state of the art. So you can't keep a secret and get a patent on it. You have to, as part of the patent application, you have to reveal the whole thing. And then other people can learn from it and build on it. But you've got a 20-year protection on the invention itself. So before I go any further, I actually want to look at a patent. Okay, so this is what a patent looks like. So this is patent 6 million whatever. It's issued in 2005. And I like this patent because it's short and because it shows you that you can patent all kinds of stuff you might not imagine you could patent. So this is a patent called Sanity System for a Video Game. And it was Nintendo holds the patent. And I suppose those are employees of Nintendo that developed the ideas behind the patent. Now, the application was made in 2000, the patent was granted in 2005. So the patent is good for, I don't remember if it's retroactive to 2000 or not, but it's still active in any case. So here's what a patent looks like. It has that information, and there's an abstract that sort of describes the idea behind the patent. So this says, you know, a video game system incorporating a game character sanity level. The basic idea is the idea of having a video game, and the character that you're manipulating in the video game can, depending on what happens to the character in the course of the game, the character loses its sanity. And as a result of losing the sanity, the gameplay changes in some way. That's the basic idea. So it doesn't sound like a, you know, an earth-breaking kind of deal. And you might argue that, yeah, that's obvious. You know, you could argue about whether that's something that ought to be patentable or not, but in fact it was patented. So when you look at a patent, the abstract's a good thing to read because it gives you a high-level view of what the patent is about. There's always a picture, an image, from elsewhere in the document that's duplicated on the first page to sort of give you an idea of what's coming up. So this is, I guess, some sort of stylized screenshot from the video game of this character you know, encountering that which causes loss of sanity. And this, I suppose, is like some health bar showing how much sanity the user has. The bulk of the patent is taken up with a detailed description of how the invention works. In any kind of software patent, it always seems to start with a description of what a computer is. I mean, here's a flow chart that shows the idea. You start with some sanity level, the game continues, there's a gruesome event, no, you continue as before. If it is a gruesome event, you come down here and your sanity level changes. You modify the sanity level and you go back to where you were. Okay, so a loop. So here comes there's that picture again, right? This is sideways, but you know, there's a picture of Mario on a display. So there's a display, there's a memory, there's a the computer with the controllers attached, and you say they're going to explain all these pieces, ADA, ADB, and so on, all these buttons, what they do. Other pictures, man, a lot of pictures. Okay, there's a typical computer again sideways, a sound card, a DVD player, and all that. Got to be text, okay. So here's the background of the invention. It's saying video games typically include a game character that proceeds through the game, blah, blah, blah. Summary of the invention, brief description of the drawings, detailed description. So if I'm evaluating a patent, I just, you know, even though that's the description of the invention, I skip to the end. Because all that matters, these are examples of things that, you know, wall carvings coming to life and reaching out for the character, an example given in here. Glowing eyes blinking in the darkness. What matters are the claims. So you get to the end, and it says what is claimed is 1. So at the end of the patent, there's a list of specific claims. That's what's patented. The rest of the patent just exists to describe the terms that are used in the claims. So if you hold a patent and you want to sue someone for patent infringement, you have to say, okay, they are doing something that violates one of these claims. So you have to be able to say all the conditions described in the claim are present in this other thing that someone did. And, you know, step by step show that the claim was infringed. I've consulted a couple times for an intellectual property law firm that I was evaluating patents. They had a client, and the client had patents and selling a product, and I was supposed to say, does this product violate these claims? And I would spend hours on the phone with the lawyers, going point by point, phrase through phrase in these claims, trying to establish whether or not it was violated. It's very, very exacting work, for which they're well compensated, I should add. So anyway, let's look at the claim. It says a method of operating a video game, including a game character controlled by the player, the method comprising setting a sanity level of the game character, modifying the sanity level of the game, there's even a typo here, of the character during gameplay according to occurrences in the game, wherein a modifying amount of blank is determined based on a character reaction and an amount of character preparation. So there's a couple typos in that claim, which really surprises me. Controlling the gameplay according to the sanity level. So that's the first claim. It's just this general idea of gameplay being affected by the sanity level, which is a product of the gameplay. And then there'll be derived claims. So 2 says, just like claim 1, except specifically step B is practiced by reducing the sanity level of the game character upon encountering a game creature or gruesome situation. Number 3 is the same, except the modifying amount is reduced if the game character has been prepared for the game creature or gruesome situation, and on and on. So there'll be a series of claims that are just like 1, except they're being more specific, and then there'll typically be another claim somewhere that, like 11 right here, is another kind of claim, and then a bunch of derived claims from it. So, it can be difficult to decide if, suppose you create a piece of software and you want to know, is it covered by a patent? It's hard enough just if someone gives you the patent to decide whether or not your software violates a patent, but there are thousands and thousands of these things, and so that's what lawyers are for, patent agents. So that's what a patent looks like. This is a short one, so it's a simple idea. There's another one I show sometimes that's referenced in the slides, which is a famous patent that Amazon got in the 90s on this idea of one-click ordering. So the idea was that, the shopping cart model is that you shop online, you fill your cart, and you go check out. So you have to click to put something in your cart, you click to check out, you go to check out, you enter your credit card information, and you click again. One-click ordering is you pre-entered all that information, and all you do is when you click on it, it's ordered. So they got a patent on that. The patent was later appealed and watered down a bit, but they got that one-click patent. That's a longer patent. You can look at it if you're interested. So, you've seen what a patent looks like. Let's talk about how to get a patent. So there's the U.S. Patent and Trademark Office. So if you want to get a patent, you have to write it up and file a patent application. Usually you hire an attorney or a patent agent to help you write the patent, or if you're working for a company, they do that. And you get the patent produced. Thank you. Now the government has patent examiners. So the job of a patent examiner is to take an application, and the patent examiner looks at the prior art. They look typically at what has been patented in the past. And their job is to determine, is this a new thing that would not be obvious to someone skilled in the art? There can be a race to file. Before 2011, if 2 people filed for the same patent, it was given to the one that could show they invented first. But now, it was changed to be consistent with the rest of the world. So now it's first inventor to file. So if 2 people independently invent the same thing, whichever one files first now is favored to get the patent. I was told that a new examiner spends about 80 hours researching a patent to see if it's valid. An experienced one about 20 hours. It takes about 18 months or longer to get a patent. And patent office, patent examiners are underpaid. Just so imagine if you are you're educated enough in computer science to be able to intelligently determine whether some patent is a new idea that's not obvious to someone schooled in the art, someone trained in the art. Would you rather have a job as an underpaid patent examiner in Washington, or would you rather have a job, actually working in the computer industry? The government isn't going to compete with the kind of salaries you could get in industry. So they're not, patent examiners are not enough of them, they're overworked, they're not always completely qualified for the field they're doing patents in, so it's a problem. It's not an adversarial process typically. It's not like you file a patent and there's a hearing and the 2 sides, your lawyer argues for it and the rest of the industry argues against it. There is the chance now, this was reformed a bit a few years ago, and so others can contribute opinions, and it's easier now to challenge patents after they are granted. But basically, once a patent is granted, it's really hard to, it takes a lot of work to get it invalidated. And arguably, patents get granted that shouldn't be granted.
That's what Einstein did.
Einstein did what?
He was a patent agent.
Oh, yeah, probably in Germany. Okay, so not enough examiners, they're not paid enough. In the case of software, there's lots of stuff in the early days that wasn't patented. I mean, who invented the for loop? Certainly that could have been patented. The conditional statement, someone invented that. The method call, inheritance. That's stuff that was never patented. Then there are patent trolls, which are companies that are in business only to acquire and enforce patents. So they don't produce anything useful. They just buy patents and then harass typically small companies that don't have the resources to defend against it, that are in violation of those patents. Sort of extort them into paying up to avoid being sued for more. The really big companies, what they do is they have a lot of employees, and so they patent anything they can think of. And so if you're Google, and you're Amazon, and you're Apple, you have tons and tons of patents. And so if Apple says, hey, Google, you're violating this patent, what does Google say?
You're violating this one.
You're violating that one, right? It's sort of mutual assured destruction. If you have enough patents, surely someone's in violation of it. So if you have enough, you're sort of secure against sniping from at least one of the big companies.
It's like the atom bomb.
Yeah, data bomb. Right? So we looked at that first one. That second one is the Amazon patent that was actually challenged and amended. There are some famous patent cases. This is the most recent one I have up here, where Apple said that Samsung violated some design patents and utility patents, like tensions on the phone. Apple won $1 billion from that. BlackBerry just about went under. I don't know if BlackBerry's a thing anymore, but they were at one point, and they were sued by a troll. Didn't take it seriously and ended up having to settle for over $500 million. And there's lots more information out there. We actually had a professor on the CS faculty that retired a few years ago that was a registered patent agent. And, he was on Orrin Hatch's staff when the DMCA was adopted. So he's an expert on this. And he created, that may be his online resource right there. There was an online resource he created talking about this sort of thing. Okay, so kind of a fast tour through patent. But it's something, if you go into business, especially if you work for a large company, you may end up on patents. Typically, at this point in the semester, I also talk about ethics, professional ethics. And I hate to spend only 5 minutes on it, but that's what I'm going to do. Not because it's unimportant, but just we're out of time. So this is the Software Engineering Code of Ethics and Professional Practice. And I'll settle for just saying one thing about it. What's the #1 responsibility of a software engineer according to this Code of Ethics? What comes first before everything else? The public interest. Software engineers shall act consistently with the public interest. That's a higher responsibility than acting in a manner that is in the best interest of client and employer. Right? It says consistent with the public interest. So there's, you're working in the best interest of the public. You're working in the best interest of client employers. You've got to produce, high standard product, professional professional products, have good professional judgment, manage ethically, and so on. But we only got 5 minutes. We might as well look at the number one responsibility. What does that mean? How in the world can you put the interest of the public before the interest of your company? What does that mean? Yeah?
I would say if you're working for a telecommunications company that asks you to build software that allows you to give users private information without their permission.
Okay. So you're working at a telecommunications company or any company that is asking you to do something that is not legal. Okay? It's not enough to say, I did it because my boss told me to. The Code of Ethics says that if it's not ethical to do, because of some public consideration, then it's not something you should do. And of course, it's hard to define this in practice. It's easy in the abstract to say, okay, your boss has asked you to create some software that will result in the death of everyone that uses it. It's easy to see that you shouldn't do that. But, ethical dilemmas come when the line is a lot blurrier than that. But the guiding principle is you shouldn't do stuff that is against the public interest. Can you think of any other examples of things that would be something that your company wants you to do, but that is not in the interest of the public? Yeah?
Cambridge Analytica.
Okay, Cambridge Analytica, of course, everyone talks about, where they obtained data on Facebook users and used it in a way they weren't supposed to be using it. Yeah?
Creating a virus of some kind.
Okay, yeah, if your boss asks you to create a virus, it's going to damage the public. Yeah?
Security backdoors in a program or OS.
Okay, so security backdoors, that could be a problem, yeah?
Attack or shut down a competitor's service.
Okay. Yeah?
Professional troll farms?
Okay. All right, so I'll just leave it at that. And usually there's a question on the final that says what's the highest ethical responsibility of a software engineer, and it's to act consistently with the public interest. Okay? If you go on with these slides, you'll see, and this is the entire code here, at least the high level view. There are these scenarios. They've gotten really old now. They're about 25 years old, I think. They were old when I first got the slides. But they just talk about, they set up scenarios and ask you to evaluate them according to the code levels. So, if you're interested, you can take a look. But like I say, the 5-minute version is right there. Act consistently with the public interest. Okay, let's take a short break and then we'll talk about final. let's get started again. Okay, so the final is on Wednesday, May 2nd, so that's a week from tomorrow. It's from 1 to 3, which is an hour earlier than you used to. It's on a day that's different from you used to and a different time, so 1 to 3. I'm going to split you up. I'm going to put part of you in here and part of you next door in 104. I don't have it like seating assignments. But maybe if you would flip a coin before you come in. If you get heads, go to 104. If you get tails, come in here or something like that. I just want to have you be able to spread out. So to have people sitting next to each other. The midterm, we came really close to not having seats for everybody. If you really want to sit in here, just get here early. It will cover the entire semester, so it's a comprehensive exam. Probably it'll be 25 questions, each worth 4 points. Easy to grade. Not a lot of writing per question. Like multiple choice, short answer. You won't be writing long stretches of code. Much more likely to be reading code, short code, than you are writing much at all. And it'll cover more than coding. There's lots of stuff we've talked about, which we'll talk about here in a second. You can bring 2 sheets of notes, front and back, printed out or handwritten, whatever, to refer to during the exam. There will be a review session tomorrow, right here, from noon to 2, where Andrew and other TAs that come will first of all go over the sample final, which is not really a sample, it's a real final from an earlier year. They'll go over the solutions to that and answer whatever questions you ask at the time. I mentioned that I just released the grades for PS10. That'll be followed before the final, I'm hoping, with PS11 and PS12. Yesterday I went through PS6 trying to deal with all the questions I had received from people about, at least through PS6, trying to resolve everything. And I'm going to tell the TAs to deal with any questions on Piazza that they've received. If you asked a question weeks ago and still haven't gotten a response, now's a good time to ask again, to remind us that you asked this question and didn't get a response. If you previously just sent it to the TA, this time at least copy me on it, so I've got a way of knowing what's been done and what's not. If you had a grading question and you asked it by adding a comment to the grade, we probably didn't see that. If you have a grading question, it needs to be asked via Piazza, because we don't necessarily go back and look for grading comments. I see them sometimes by accident. Okay? So I'm not asking that we reopen can of worms. I don't want to see anyone say, I still think I should get 1 more point on PS1. That's old news. On the other hand, if we didn't even record a grade for you on PS1, it would be nice to hear about it now. I can always correct mistakes in the future. If you come back over the summer and say you forgot to record PS1, I will record it and change your grade. It's just a lot easier if we deal with this now instead of in the middle of the summer. Right? There's red tape to changing. It takes multiple people's signature to change a grade after the fact. So it'd be a lot simpler just to get all this ironed out, hopefully before the final, so that we can then give you grades. We'll be grading the final shortly after, either the day of or the next day. And then the finals will be available in my office for you to look at, but not to take. So the best time to look at your final would be sometime at the end of next week, because by the following Monday I'll have final grades to post. Okay? Any questions about that or any of these ground rules this semester? Not the whole semester, about grading. How many of you think how many of you have a sort of an outstanding, unresolved grading issue? Wow. There's a lot of you that have PS9 regrade requests that aren't resolved yet, so I guess you're not counting those. I'm just noticing a whole pile of PS9 notes. So anyway, I don't want to base the grades on bad data, so let us know if there are any things that need to be corrected. I guess the takeaway is people that come to class don't suffer grading problems. That is a reason to come to class. Okay, now we got, about half an hour, and I've got all these slides that talk about the impressive pile of stuff that we've talked about this semester. And if you don't interfere, I'll just drone on about all this stuff. But I'd much rather answer your questions. Now, I have a friend, Peter Jensen, who tells me students don't really, in a review, they don't really want to know, they're not so interested in what they've learned. What they really want to know is what's going to be on the exam. And I've told you about all I can about that. It's going to be short answer. The exam should be easy to take. I'm not saying the question is necessarily easy, but it's not like you have to write paragraphs. And easy to grade. And it will cover throughout the whole semester. But as we go along here, any questions at all, I'm happy to ask. I'd much rather answer questions than just read these slides to you. So at a very high level, what we've done this semester is talk about C#. Using C#, you've seen some programming techniques that many of you have never seen before. We've looked at a variety of software architectures. If you think about PS1 through PS12, it's been different kinds of programs using different techniques. You've used a variety of software development tools, most of them built into Visual Studio, but still, a large variety of tools that you've been using. You have hopefully improved, honed, focused your personal software practice. And you've learned more about yourself as a programmer, the kind of mistakes you make, your strengths, your weaknesses. Hopefully you're getting better at developing software. And then there have been other topics, like patents, for example, is another topic that doesn't really fit into the above. Okay, going forward, those of you that are CS majors will take 3500. And that's a class that's, you'll learn C++, which is useful in its own right. You'll also learn about working in larger groups, learn more about software engineering in larger groups. But after that, the rest of the classes you take, people aren't going to be teaching you programming languages, they're not going to be teaching you software engineering practice. You'll be applying stuff, be using what you know in those classes. So what you need to become ideally is a lifelong learner. Once you've seen a few programming languages, it gets easier and easier to adapt to the next one. And that's a good thing because that's what you'll have to do. So any questions so far? Does this raise any issues? Yeah?
Is that 3505 that's C++?
Yeah, did I say something else?
You said 35. I just was listening just to verify it.
Okay, 3505 is what I meant to say. Yeah. Yeah?
Are we going to be using C++ for everything in that class?
Yes. Yeah. So it's C++, it's Linux, and as the IDE, they use Emacs. For whatever reason. Okay.
Can we install our bin debugging?
What's that?
We can have bin debugging to our Emacs, right?
Yeah. Okay. That really got a reaction. That's interesting. So let's talk a bit about C#. That was the first thing on the list there. So hopefully by this point you can appreciate the fact that solutions can consist of multiple projects. And there are lots of types of projects that we've used. Console applications were the first. In the spreadsheet project you did a lot of class libraries that were just unit tested but not really useful programs by themselves. Windows Forms applications like PS7, PS8, which were GUI, that use class libraries. You did a lot of test projects, and then more recently web projects, the service projects, PS9 and PS10, and then really PS12. There was a lab where it talked about installers, so there are lots of projects. There are more projects supported by Visual Studio. Projects correspond to assemblies. So when you compile, you get an assembly, either an EXE, which is an executable, or a DLL, a dynamically linked library, or a website, or whatever. We made a lot of use of XML, and you should appreciate the fact that when you compile, you're compiling to what's called the Common Intermediate Language. So all the .NET languages compile to that same language, and it runs on an abstract machine called the Common Language Runtime. And if you substitute Java for C#, then you're talking about the Java bytecode, which runs on the Java virtual machine. So it's the same idea as Java, just different technology. And because of the fact that all the languages that are integrated under .NET compile to the same thing, they can interoperate. One method can call one in the next. Like a method in one language can call a method in the other language. And you're doing it all the time. When you use the .NET libraries, there's no guarantee that the library methods you're using are written in C#. It just doesn't matter. Okay, so they're tightly integrated. Contrast that with REST, which is sort of, on one extreme, languages are so tightly integrated that they're interoperable. On the other extreme, with REST, complete language independent, and it's sort of a much clumsier way of making method calls going over the internet. So, two approaches to interoperability. I tried to list aspects of C# that we've learned. There sure are a lot of them, so I can't guarantee I got everything on the list here. Namespaces and structs and classes and interfaces, IEnumerable, delegates, tasks, synchronization, sockets, TCP, GUI clients, SQL, HTTP service methods. I'm sure you could think of things that are missing there. We did this without a whole lot of, early in the semester we would spend about every other lecture talking about some aspect of C++, but eventually it became a lot faster.
C#.
C#. Thank you. But any questions about any of this or anything else related to C#? Yeah?
Just briefly explain, one I always had a problem understanding was yield return.
Okay.
Just some of its functions.
Okay. So the idea behind yield return, so iterators, is a way of implementing the IEnumerable interface. So maybe you want to produce a collection of things. And rather than create the entire collection, put it in a list or a set, and give that back to whoever needs it, when you use iterators, yield return methods, what you're doing is generating one at a time. So you generate one, and then it's consumed back at the caller. Then you generate the next one. Then the consumed back at the caller. So you've got a loop in the caller. The caller is looping through the enumeration, and your iterator is generating the enumeration at the same time. So generate, use, generate, use, generate, use. So you can have an IEnumerable that generates all the prime numbers. Right? That wouldn't work as a method that returns a set because there are an infinite number of prime numbers. But you can write a loop that spits out one prime number at a time. And the mechanism lets you, the loop that's consuming the prime numbers runs, you can think of it as in parallel with the loop that's producing the prime numbers. That's the key idea. Yeah?
Is that an example of lazy evaluation?
Okay, he said, is that an example of lazy evaluation? It's not implemented using lazy evaluation, but that is also an argument for it can also be used as an example for a lazy evaluation approach. We didn't talk about lazy evaluation, so I won't press on with that. But it's just a way of producing a collection one element at a time without having to. I mean, imagine if you just need the first 3 elements of the collection. Why pay the price of creating the entire collection and then just using 3 elements when you can get by with just do the first 3 and then end it all? Yeah?
For the final, will we need to know a lot of like specific syntax of like method names to deserialize something, or remember all those specific
Yeah,
calls?
no. You know, we're very flexible. If we ask a question, you know, if you get the syntax wrong, as long as it's close, as long as we understand what you meant, we're okay. I'm not going to ask you to write an annotation that would be used on one of these web services, but I might be interested in you being able to read an annotation for a web service and know what that means. Yeah?
Regex.
Yeah, regex, that should be on the list here. Yeah. So you should be able to write a simple regex, read a simple regex. And let me just add, I hope that going forward, whatever language you're in, that you are able to recognize a situation where a regex is called for and not be afraid to use one. When I don't use a regex when I should, it's usually just out of laziness because I just can't instantly remember how to use them in such and such a language, and I don't feel like looking it up. But it always pays off to bite the bullet, use the regex. It'll save you time in the long run. There's another hand up there that won't do.
Could you touch on client server, just like an overview, like a really high view of the interaction, I guess?
Yeah, I mean, client server, typically the idea is that it's a distributed application. So think of a client running on a computer somewhere, and out on the internet are multiple computers, each running their own client. And so the clients interact with the server. Essentially, they ask for a service and they get a response back. They don't interact with other clients. So if you like, think of the game you did, the Bible game, you were never communicating. You don't even know who the other opponent is. You certainly don't know. You just know their nickname. It's all through the server. Contrast that with peer-to-peer. So a peer-to-peer solution would be forget the server. You just have a bunch of clients, and somehow they find each other and communicate directly. Okay, any other questions? Okay, so there's a lot to know, a lot we've learned about C#. A lot of ways I could ask questions as well, but again, I'm not going to ask you to write. If I ask you to write code, it'll just be little bits of code. So this is, I should have had this up when I was answering the iteration abstraction question, but I forgot it was coming up. If you're still confused by iteration, the thing to do, if I ask you to write something that enumerates the hailstone numbers, like this, if you can't figure out how to do it using yield return, just change that type to void and write a method that prints out all the hailstone numbers. So what would you do? While n is greater than 1, we would print n, so console.writeLine n, and then we would do this. Every time through the loop, we're printing out a number, and the loop ends, we print out a number. You can all do that. That's 1410 type stuff. Write a method that prints out a sequence. So then, to turn it into an iterator, we add that back as a return type and replace the print statements with yield returns. So what would have been printed is being yielded, so it would be consumed elsewhere. Yeah?
Does that have anything to do with threading at all? Like, is that
Nope. Has nothing to do with threading. You can think of it that way. You can think of they're being generated on one thread and consumed on another. But the way this is implemented, what the compiler does is it takes this code and dices and slices it and rearranges it into the implementation of a custom class that has state, that has a move and a get next method. And then that object is consumed by the loop. So when you have an enumerable object, it just provides a way to get the current value and to move to the next one. And this code is cut up and used to implement those methods in the custom class. So it's not, no multi-threading. That's a convenient way to think about it. The abstract way to think about it. But don't be too concerned about how it works. Just understand the idea behind it. Okay, any other questions? Okay, I told you at the beginning of the semester that delegates were important, and there weren't things that, you wouldn't be able to hope it would pass. There would be no need to understand it at some point, because as we went forward, there was just more and more stuff that required delegates. Most recently, sockets. Interacting with sockets required delegates. Launching threads required delegates. Events involve delegates, and on and on. So it's just a word for passing treating a method as a value, storing a method in a variable, passing a method as a parameter, returning a method as a result. It's conceptually simple, and the only thing that makes it complicated, if you want to view it as complicated, is that when you pass a method as a parameter, just like anything else, you got to give its type. You've got to say what type of method can you pass. And this one wants one that takes 2 minutes and returns a bool. Okay. Other than that, you might wonder how it's implemented, but besides that, it's really not shouldn't be a mystifying concept at this point. But, any questions I could answer? I'm not saying it's bad if it is mystifying. I'd like to demystify it. All right, some languages make bigger use of them than others. What about Java? What does Java do? Yeah? Right, traditionally, you did, like the sort method in Java, you didn't pass a delegate to it. You passed an object that contained a method that did the comparison. So the object was of a class. The object was of a class that implemented the comparable interface. So rather than passing a method, you pass in an object that provides the method. But lately, more recent versions of Java, rather than having to actually create such an object, there are ways to basically use lambdas to be very brief, that turn into object class implementations.
Instead of delegates like rely heavily on what we call now the functional interface, which basically the lambda or anything creates basically an anonymous class.
Right.
That wraps that interface.
Yeah. So it makes you. So you're going to write what look like lambdas in C#, except one of them uses equal sign greater than, the other uses arrow greater than. And I'm standing here right now, I can't tell you which. I can. C# uses that. In Java, it would be a dash followed by a greater than. Yeah?
I'm not sure if I'm correct on this, I have some clarification. On the first line, we have delegate pool comp, and that defines delegate type.
This is just a declaring type. So it's basically, now in the future, you can use comp to stand for, is the type of a method that takes 2 minutes and returns a boolean. So now you've got comp.
And on the third line, we have function in the pool. That's basically the same thing, only one's done inline, the other one's
Yes.
done out.
Right. So if you're only going to use it once, maybe that's better.
Okay.
If you're going to use this a lot of times, maybe you want to name it and use the name.
Okay.
And C# has been through lots of versions, and every now and then they introduce yet another way to declare or talk about delegates. And occasionally you'll run into some old library code that won't, you find yourself, you think you ought to be able to pass a method as a parameter, but the types don't match up and you've got to explicitly cast the method to some type. And it just has to do with sort of the age of the part of the API. C# Java's been very slow to change and careful to be backwards compatible. C# on the other hand has been willing to just forge forward and leave a little bit of mess in the wake. Anything else? Yeah.
Probably a really dangerous question to ask, but what do you think is a more useful way? Who handles object-oriented programming better, C# or Java?
I like C# better. It just, if for no other reason, Java has the annoying erasure semantics. And what that type erasure? What that means is in the Java virtual machine, in the Java bytecode, there is no way to talk about list of int, list of double, list of string, list of whatever, that information is lost. When it's compiled to the bytecode, it's just list. And what that means is that you can take an object that you know is a list of integer and pass it into a method, and when it comes out and you get it back, it's just all you know is a list. So there are all these situations where typed information is lost when you use the API. And this was because the designers of Java did not put parametric types into the original language. They added them later, and it's just not, very satisfying. Like you can't have a list of int in Java. It has to be a list of integer. So there are lots of other reasons. It's just a more refined language in Java. And it's also faster. In 4150, every week the students do a problem on Caddis, which is a programming contest site. And they've got to write the program. They implement some algorithm that has to be faster than some limit. And they can use whatever language they wish. And C++ and C#, there's not a lot of difference. C++ is faster, C# is a little bit slower, Java is way slower. So typically Python is faster than Java. Anything else? Yeah?
Since you mentioned it's about Java and C#, I found myself thinking when I used Java that it was all clear-cut and organized and very abstract. But then in C# there's lots of little teeny nitty-gritty details like out parameters and that rely upon knowledge of the computer, sort of the runtime memory model and stuff like that. And I suppose that gives you more power, but it seems it's a little bit imperfect because it acts like it's as abstract as Java most of the time until suddenly some sort of low-level detail hits you in the face and you're trying to look at what it means.
Yeah, I mean, I can see that point of view as well. Java's simpler. Okay, so C was created around 1970, 1972 or something. And C was designed to be a high-level language that let you directly get your fingers on the underlying hardware. So you could write code as efficiently as you wanted to and compete with assembly language. A language like Java, it was designed to take you away from the machine level. C# was sort of a compromise between the C++ approach and the Java approach. So they put enough bells and whistles in the language that if you choose to, you can deal at a low level with, you can make low-level trade-offs that you can't make with Java. So Java is a higher-level language, I would say, than C#. But yeah, taste vary. I mean, if I'm sitting at a computer and someone says, write a program in 5 minutes, I'll do it in Java. Because I can write Java without starting up an IDE. I could write it and compile it in the command line pretty quickly. So it had, I use both languages a lot. Okay? So we talked about events, another use of delegates. Just things that asynchronously trigger calling. So know what an event is. We spent a lot of time talking about threads and tasks. Okay? And I don't know if I have, it looks like the await async pattern didn't show up on here. But you remember how on the midterm there was a question of, I gave a method that used some threads and you're supposed to say, in what order are things going to be most likely printed out? I can ask questions like that on the final, but I can throw in await and async. So even though you may not have used those in the program as much, you should understand how await. Let me see if it comes, it's not there, I'm going to add it here. Remember to post it. Okay? We've done socket programming recently. So understand how those asynchronous socket works. I mean, after PS11, hopefully you understand that. And let me just give you a meta hint. PS6 PS7 through PS12 was pair assignments. So suppose you broke up PS10 such that your partner did one part and you did another part, and as a result you didn't learn about how to do a join. You never wrote code that used a join. Well, it'd be a good idea to learn how to use a join. So just remember, you need to understand how the various projects work, including the parts you didn't work. So at least look at your partner's code, understand it all. We talked about accessing SQL, how to use SQL, how to access databases from C#. So you certainly understand basic C# queries. One thing we didn't, SQL queries. One thing we didn't talk about was LINQ, which is, it's a way that you can do SQL-like queries against C# data structures. So let's say you have a set, and maybe you have a couple sets, and you want to combine information for the two sets. You can treat the sets as if they are relations, and you don't actually write SQL queries, but they're methods that will manipulate these sets as if they're SQL relations. So you can think in terms of database queries, even though you're not using a database. We talked about a lot of architectures. We talked about the object-oriented architecture to start. That's just sort of what you learned in 1410-2420. We used a client-server approach for some of our assignments. We used a pipe and filter approach for PS1. Event-driven architectures in PS7 and PS8. We did clients. A GUI architecture in the same places. Model view controller for our servers. Used database kind of architecture in PS10. RESTful architecture in a bunch of those. So that's a big scope. You've done a lot. You've been exposed to a lot of different ideas. It's not all the ideas there are, but it's a lot of stuff to confront and deal with in a semester, 1 week at a time, fast pace. I'm sure maybe you found the class grueling, but you rest assured you've given yourself a good foundation for moving forward. That's a list of some of the software development tools you used, in case you had forgotten. Almost all done inside of Visual Studio. If you didn't get a chance to do the lab where you do the cloud deployment, when you get some time after the semester, why don't you try doing it? A student should get a free Azure account. And it'd be pretty cool to get your server working on the cloud. Then you could, anytime, then your clients can use your server when it's running on the cloud, or anyone else's for that matter. Kind of neat to see it happen. We talked about, especially early in the semester, we'd have lectures on what's software engineering. Basic idea is just sort of the problem of organizing a bunch of people to solve a technical problem using software. So it's not just a software issue. It's management, it's psychology, it's computer science, all put together. We made large use of version control. Now, I'm convinced there's two kinds of students. There's the students who, when I say, merge this branch into that branch and make this change and go forward, what they do is they merge this branch into that branch and make this change and move forward. And the other kind of student, copies and paste from GitHub. They bring it up on the web page and copy and paste because they just haven't figured out Git yet. If you're in the second group, I really encourage you to practice and get better at using version control. Become used to using it. And apply it outside of this class. Don't just say, I'm glad that's over with. You're not going to get far in computer science these days without understanding Git. So the more anything you can do to hone your talents will be repaid many times over. You did a ton of testing. We talked about some issues related to testing that you ought to understand. But, you've got plenty of practice with testing. And with debugging. You feel you got better at debugging? I think I've asked this before. Yeah. I know I get better at debugging every time I teach a class like this because I end up doing debugging in my office. You experience writing to a specification a lot. Especially like PS5 and PS6. There were plenty of folks on PS5 and PS6 who just didn't quite either read the specification well enough or understand what it was saying, and failed a lot of test cases. Fortunately, there was a regrade mechanism, so they could get most of the points back. But, I don't know. I've got XML and regular expressions in here, so we talked about that before. SQL. Several times I talked about runtime, the runtime stack model. So if I do ask you to write a stack and heap model of some process, just remember, just don't draw boxes all over the place. Right? Stack frames need to be organized into a stack, a vertical rectangular thing. Then the heap is out here with arrows to it. You wouldn't believe what I see when I ask a question like this on a test. To the point where I won't ask you to write a stack diagram on the test, because I'm tired of looking at it. I may ask you I may ask you questions about the model, or maybe ask you to read one, but I'm not in the mood to grade one right now. And here at the end we talk about intellectual property and ethics, so I won't belabor the point. So we're out of time here. The TAs will not have office hours after today. I will, though. I'll have my regular office hours Wednesday and Monday, and I'll be answering questions during that time. If you have more detailed, specific questions, go to the review, and Andrew and the other TAs can help. Otherwise, I'll just see you in a week. It's been a blast.